Okay, so let's see where we left this guy off. Do we have one tower functionally working? But with no rules associated with it, right? All right, so I can click there. I can put it back. All right, but none of the other towers let me do anything. All right, so step one, we're going to break this down into little pieces. So let's open up our Keynote here. I'll give everybody a free quiz this week for Thanksgiving. Sound good? Yeah, I'm going to Branson. I'm going to, so I got a 12-hour drive in front of me tomorrow. Yeah, so I should make pretty good progress on my audiobook, I would think. Wednesday night is not. So, because classes after 4 p.m. are not supposed to meet. Yeah, see, this Thanksgiving really kind of screws up. Yeah. This because like, I mean, I'm probably not going to give you a homework assignment over break. I probably should give you a homework assignment over break, but the problem is that I mean, you know, I want you to go places and have a break and this kind of stuff, but now we lose a week, so I'll have to give you a double assignment. See, he's excited about it, you can tell. But then you have the whole flip side thing where students wait till the day before the assignment's due anyways to start, right? Or was it the morning of? Did you start this morning? Did you even start? Okay, so let's think about the pieces that we need to solve this. So kind of the writing portion of our assignment this week. All right, so what currently is working is we have 3 stacks. One stack we can move things away, put things back. All right, so we need tower 2, move things away, put things back. Tower 3, move things away, put things back. This is completely forgetting about logic with these things. So we're going to say tower 2, functional. Tower 3, functional. Tower 1 logic. Tower 2 logic. Tower 3 logic. So that's going to be whether or not you're allowed to put something on or off the towers, right? So this means just make the towers work so we can move disks everywhere in the game. This means before you put a disk on here, before you allow a disk to be put on here, it follows the rules, follows the rules, follows the rules. Okay, then we need to have the ability to know when we've won. Winning logic, right? And then we need to be able to count moves. Yep, so are these kind of all the pieces? If every one of these boxes turns green, have we accomplished the assignment? Anything we're missing there? Yeah.
Our logic will be only the same logic for all the time.
That's fine. So we'll get three red green lights pretty quickly, won't we? But we need it to work on all of them, right? Wouldn't you say that it's going to be the same logic to make these two towers work as this one? For just functional? It's going to be the same logic, right? But right now, it only works for this one. So we need to be able to check this one off and check this one off. Make sense? So if every one of my towers is functional, and then every one of my towers follows the Towers of Hanoi logic, and then I'm able to detect a winning position, and I count each move, have I accomplished the homework?
Oh, yeah. Are we supposed to count the moves too?
Right there, count moves.
Yeah, I thought you said that was the next step.
Oh, did I put that on the homework assignment?
Yeah.
Oh, that's fine. Well, we'll put this over here as a little extra. So we'll put that in blue. This is version 2. It'll be a version 2 feature, but we'll put it on there. Okay. So this is kind of what I wanted you to come up with for your writing assignment. So describe the entire problem you're trying to solve, and then break it down into your small pieces. Now we're not trying to just solve Towers of Hanoi. Now what are we doing is we're trying to make Tower 2 functional. That's it. I want Tower 2 to work just like Tower 1 currently works. I want that to happen when I click on Tower 2. Make sense? But when I click on Tower 2, if there's nothing here, I must have to come from our guy up here, right? So we have management associated with our waiting zone. When I click Tower 1, it's going to take something from the top of Tower 1 and bring it up here into our, whatever we called it, our loading area, okay, to our loading area. Now, I can put it back into Tower 1, but our game is kind of in destination mode. So initially, our game is in source mode. Now our game's in destination mode. So let's kind of throw that in there now that we've kind of discovered that type of thing. So we're going to say source mode. Destination mode. So difference being, am I retrieving from the stack that I'm currently hovered over, or am I putting onto the stack that I'm currently hovered over? So right now we presume that since I last pushed this button, I'll go ahead and put it back. So the game starts off in source mode. When I click a button, I am sourcing a disk from that tower. And assuming there is a tower to source from, I put it into my loading zone, then I switch to destination mode. Now when I click on Tower 2, because the game is currently in destination mode, when I click on Tower 2, it knows to go ahead and take the disk that's in the loading zone and put it into here, and then switch back to source mode. Make sense? All right, so let's go ahead and get that source destination mode logic taken care of. So source mode by default, now we're in destination mode. Now we're back to source mode, destination mode, source mode. Make sense? Okay, now do we already have, so we'll go into our main activity here. And we're going to go ahead and say private bool is, oh, it's Boolean in this language. Is source mode. And we're going to start this off as true. All right, so we're going to have a Boolean that's going to keep track of whether or not we're in source mode. And it'll begin as true. Now for our towers, This guy, let's see, does he know about his button? How are we currently doing the button? So on create, here's tower 1 button pressed. Okay, so we have this logic for tower 1 button pressed. So why don't we now, do we know about our towers? There's our disks. There's our tower. So why don't we go ahead and use this one function? We talked last time about how we can use the one function to handle multiple senders for who click the button. So why don't we call this guy tower button pressed? All right, we'll call this guy tower button pressed. Now, we're going to ask ourselves if this dot is source mode, then we're going to do some stuff. Else, we're going to do some other stuff. So this guy is going to be try to retrieve from the appropriate tower and put onto landing zone. Okay? Our else is try to take from landing zone and place on appropriate tower. All right, so now based on that, we really have a couple of, well, really that's this piece here, the source mode versus the destination mode. And then that's linked with our tower logic, right? So we could split our tower logic if we wanted into two pieces, source tower logic, destination tower logic, if you wanted to break it down further. Okay, so if we're source mode, we're going to try to retrieve from the appropriate tower. Now we need to know which tower called this. So we have to ask a question about V here. So what I'm going to do here is we're going to create, so let's see. So there's my tower. Does my tower know about his view group? He does. Does he know how to let me know about his view group? He doesn't. So what I'm going to do is, because we want to be able to ask the question here, I need to know about the buttons themselves. There are 3 towers. We don't have the buttons associated with them. Trying to decide whether it actually makes sense to do this as one function for 3 towers or 3 functions for each tower. I think it might make the most sense to deal with 3 functions, because we're not grabbing the buttons associated with which tower you've done. So we originally called this guy tower 1 button pressed. This is going to tell us which kind of tower we're in. So if we're in source mode, then what are we going to do? We originally determined if we were in source mode based on this, this temp thing, right? So now we're going to actually call it source mode. So when temp was null, that means we were in source mode. When temp had something in it, that means we were trying to put it into a destination. Right, so if temp is null, that means we're in source mode. And what are we going to do? We're going to ask whether the first tower has something. If it does, we're going to pop and then add it to our landing zone. So let's take that piece. All right, now I actually don't need the temp part because we're using our source mode thing to handle that. Temp is just our landing zone. All right, so if we're currently in source mode, if we have something at the top of tower 1, then we're going to go ahead and pop that into temp. add it to our landing zone, and say this dot is source mode is equal to false. So now we've gone into destination mode. All right, now to make this guy a little bit easier, I'm going to take this logic. We're going to call this private void tower logic. This guy's going to take a tower T as a parameter. So I'm going to take this if else from here. We're going to put it inside of this function, this tower logic function. We're going to ask if T dot peak is not equal to null, then T dot pop like that. That way we can call this guy and we can pass him the tower that we want him to check. So we're almost accomplishing what I was trying to get to accomplish before. You'll see this here in a second. All right, so this is what we do if we're in source mode. So if we're in source mode, we look at the tower that we're currently interested in. That is the tower that was passed into this guy. So then down here, we could pass each of the 3 different kinds of towers. So we look at the tower we're interested in. If there's something at the top, we move it from that tower into our landing zone and mark ourselves as no longer being in source mode. Otherwise, we must be in destination mode. So what are we going to do? We're going to push it onto the tower. Initially, remember, we're not creating any sort of special logic. We're just making function, right? So we're going to go ahead and we're going to take the tower that we're going to for our destination. So we're going to say so temp holds my actual disk. This guy's the disk. Landing zone holds the view. So I'm going to go ahead and I'm going to say this dot landing zone dot. Let's actually do that. Well, I need to do it first in this initial logic. So I'm going to say this dot landing zone dot remove all views. So we'll empty that out because we can't have our view live in more than one place. All right. So we'll empty the views out of our landing zone. Now I want to take whatever's currently in temp and I want to push it onto my tower T. T dot push this dot temp. And then this dot temp is equal to null. And then this dot is source mode is equal to true. Switch back into source mode. Really, the source mode and the temp, these guys are both doing the exact same thing. We could interpret temp to tell us whether or not we're in source or destination mode. That's what we were doing before. But now, since I specifically said it would be interesting to know which mode we're currently in, we just gave ourselves a flag to keep track of it. So we're just having to manage 2 variables. We know that when temp is null, we must be in source mode. We know that when temp has something, we must be in destination mode. Okay? So this will bounce back and forth between those. So our landing zone, remove everything. So the view associated with the disk is gone. Then push it onto the tower. If we go into our tower, we see our tower has a push. And this, we add the view of that tower to from the disk to our tower. So in order to be able to legally do that, we had to remove that view from our landing zone. All right, so remove it from the landing zone, push it onto the tower, which should add it to the tower's view. Empty out temp, flip the switch for source mode. So this is our tower logic initially. Really, this is tower function. So what we'll say here is we're going to say this dot tower logic, this dot T1. Then we're going to create 3 more versions of this. This is tower 2. This is tower 3. This is T2. This is T3. So we wrote the logic once, passed in the tower that we were dealing with each time. Make sense? So now we just need to hook up these other 2 buttons to the correct guys here. So we'll click on tower 2. On click. Do it again. Here's our tower 2 button. Tower 3. Here's our tower 3 button. Go ahead and run this. So we're in source mode. Now, I did not flip into destination mode there. Why not? Because when I'm clicking on that tower 3, I'm in source mode right now, but when I clicked on tower 3, it's asking the question, if I'm currently in source mode, which I am, only if I have something there do I flip into destination mode. Right now, I have nothing in this tower 3 tower. So source mode, source mode, source mode, source mode. I'm not flipping the switch. But now I can move from here, push here, move from here, push there, move from here, push there. Now we have a functional pieces there. All right, so we'll come in here. We're going to say our tower 2 is functional now, and our tower 3 is functional. We also have source mode and destination mode handled. Source mode, destination mode. All right, well now we need to determine our logic. Okay, our logic says that a disk that is bigger than only disks that are smaller than the top of the destination tower are allowed to go in there, right? Now what we can do is we can put this logic into the tower itself. So that means that from our game, we could try to throw a disk at a tower. And the tower could say, okay, will this disk fit? Now let's look at the order in which we're doing things here. If we're inside of main activity, when I'm in destination mode, the very first thing I'm doing is I'm removing everything from the landing zone. Now, if I rely on the tower to determine whether the disk is a legal move or not, if it says no, I'm going to have to come back in here and add it back to my landing zone. Right? Or I could ask the question first. So I can either put my logic here that says, is this move going to be allowed? Or I could put my logic in the tower. So what would it mean to put the logic here? If I'm asking, am I allowed to put the disk that's currently in temp onto tower T? I'm going to have to peek at the top of tower T, right? So I already know that I have a disk here that has a size, right? If we go to our disk stored in temp, this guy has a size, and I have a get size, so I can get his size. I'm allowed to push this guy as long as his size is less than the size of the disk at the top of my destination tower. All right, so we can ask the question like this. We can say, if t.peak is not equal to null, so if there's a disk there, well, let's write the compound thing first, and then we'll see why this might be somewhat of a problem. So if there's a disk there, and this .temp.get size is less than t.peak.get size, the disk that's in my landing zone is smaller than the disk that's currently at the top of the tower, then I'm allowed to put it on there. So I'll remove it all the views. I'll push it, reset everything. But there's actually one additional condition that says I'm allowed to push the disk onto that tower. This says if there is a top disk and the guy I'm trying to push on top is smaller than him, allow me to push it. What other condition, under what other circumstances are we allowed to push the disk on? The tower's empty. So I need to ask that in an OR. So I'm going to say if that whole thing is true, or t dot peak is equal to null. So two different Booleans, right? So if all this is true, or just this is true. See how that's working? Now it's a pretty complex Boolean expression. If you're not comfortable with something like that, you know, we can certainly ask the question a little bit differently. We can say, if we really wanted to stretch it out, I guess we could say, if t dot peak is equal to null, then go ahead and do this logic. Else, if t dot peak is not equal to null, so we'll say, so in this else, we know it's not equal to null. So then we'll say else if the thing we're trying to push is allowed, then we would do this logic. These are the two different circumstances by which we can move the disk from our landing zone over. So we have to duplicate our code twice here. But maybe we like the asking the questions are a little simpler. If it's empty, or if I'm here, if I'm in the else, we know it's not empty. So now we can ask the question, if the size of the thing I'm trying to push on there is smaller than the size of the thing that's on there, then it's allowed. So if you like these Boolean expressions better, you can write it this way. If you want to make it more compact and not have to duplicate code, we would write it this way. We're asking two separate questions in here with an OR. If either of these conditions are true, do the stuff. So let's run this. Well, we don't need to, it'll just won't leave from there. And we'll still be in that mode. We'll still be in destination mode. All right, so right now, I'll come from tower 1. We'll go ahead and put this on tower 3. I'll go from tower 1. I'll try to put this on tower 3, but it's not allowed, right? So we're still in destination mode. I can now put that onto tower 2. If I go from tower 1, I can't put it on tower 2. I can't put it on tower 3. Only thing I do is put that one back in tower 1. I can take this guy and put him here. I can take this guy, I can try to put him here. It doesn't work, but I can put him here. I can take this guy, put him here, this guy there, this guy there. So we have our logic now. So now we're playing by all the rules, it seems like. So that's those pieces. We have our tower 1, tower 2, tower 3 logic. So now we just need to determine when we won. Because really, this guy should be telling me I won. All right, so how do we know that we've won? Well, what condition? Just as a human being, have we won here? We look at, is this winning? This is winning. How do you know? Yeah, all the discs are in the last tower. So the tower count is 3, and the only tower we actually care about is tower 3. So let's look at our towers. Do towers know how to tell us how many discs have been entered? No, we haven't taught them how to do that. So one thing we can do is we can allow a tower to count. Every single time we push something onto the tower, we add 1. Every single time we pop, we subtract 1. So we can create a private variable.
Do stacks like keep track of those indexes? Can you just use
Well, we wrote the stack, so we're not keeping track of indexes here. It's just a linked list. So when we push something, we just set the top equal to that guy or set that guy's next equal to what top used to be and then make top point to him. So we're not keeping track of any indexes, but we certainly can keep account of an integer and just say, hey, whenever you push something, I'm going to add 1. Whenever you pop something, I'm going to subtract 1. So if we do that, won't count always be up to date? So when we push, this dot count plus plus. When we pop, this dot count minus minus. So now a tower knows its count. Now we do need to give it a way to get the count because we made this a private variable, right? And we're good programmers, so we make it private instead of cheat by making it public. That way we don't have to write a getter. Okay. We're going to write the getter. So we're just going to come in here real quick. And, well, we'll let this guy write it. So we'll say generate getter for count. There's my get count. So now I can ask a tower what its count is. And we actually only care about one tower, right? We care about tower 3. We want to know whether tower 3 is if its count is 3. Now, we wrote a more advanced game of Towers of Hanoi. Like if you looked at the website, you could choose the number of discs that you start with. And then, so then 3 might turn into 7 or something like that. You can also change the number of towers. You can have 500 discs and you can have 200 towers. It's the far right tower that we care about. And once it has all of the discs, it's 1. Make sense? So ours isn't all that generic of a solution since we're assuming 3 towers and we're assuming 3 discs. But it wouldn't be horrible to expand this if we needed to. So now what we'll do is now under what condition might we have just won? What must have just happened for us to possibly have won? Yeah, if I'm playing the game, let's start this over here. Right. So I'll go ahead and click this. Now, could I have just won? Is it even possible that I could have just won? No. I have to be, I have to be in destination mode. So I had to have just made a move. So when I go here, I potentially could have just won, right? Because I was in destination mode and a move was made, okay? Now, so not only being in destination mode, but also basically having switched back to source mode after making a move, after successfully making a move. So for instance, if I come here and I try to make a move here, even though I'm currently in destination mode, this move did not occur yet. So not until this guy actually drops could I possibly have won. Make sense? So I need to be in destination mode and I need to have successfully placed the disc. Only then might I have won. And then I can just ask the question, if Tower 3's count is 3, I'm a big winner. Make sense? So we'll come into our tower logic here. This is in our main activity. So here's our else. If we're in destination mode, here's where I've made my move, right? So I'm gonna write another function just to separate these things a little bit. So I'm gonna say private void check for winner. I'll call check for winner there. And check for winner is going to ask about that last tower. It's going to say if this dot t3 dot get count is equal to 3, system dot out dot println winner. Make sense? Go from here to here, here to here, here to here, here to here, here to here. All right, we should see winner pop up down here. So we'll look at our Android monitor, and there is winner. Make sense? Now, unfortunately, I can keep moving. So no longer a winner, but now I get to win again. So I get to win multiple times. All right. Not a winner, winner. Okay. Back in here, we have our winning logic. All right. So now, we got all green. Homework's done. Make sense? All right, so now we might want to count the moves. How many moves we made to get us to be a winner. Now, when is a move actually made? Yeah, so same situation where we're checking for a winner, right? That counts as a move. So we'll come back in here. And we're going to say private int number of moves. And this guy will start off at 0. Each time we make a move, we'll say this dot number of moves plus plus. And then when we check for a winner, we'll say winner. We'll just do it as a separate line. We'll print out the number of moves. So every time we successfully do a push, we add to our number of moves. Now the fewest number of moves we can complete the easiest, the traditional tower stuff in noise in 7. All right, so there's 1 move, 2 moves, 3 moves, 4 moves, 5 moves, 6 moves, 7 moves. So there's my 7. Now we're going to keep counting. Now we're at 9 moves. Still a big winner. All right, so now we're counting correctly for number of moves. All right, so now it might be nice to actually show up top the number of moves we have. Right? How would you do that? Instead of waiting just for the end for us to see how many moves we are, kind of see the progress. I think the little Towers of Hanoi example we had us showing us the progress along the way. So we'll know whether it was move 1 or 2 or 3 or 4 because we would Instead of having to remember it in our head, we would see it on the screen. How would you represent that? All right, so put a text view up here. So maybe put it above where our landing zone is. We'll go back here to our activity main. Let's shrink that guy down. I guess we can keep that out. It's not going to hurt anything. All right, so let's now go ahead and give ourselves a, let's just look. So here's our landing zone. This is in a vertical linear layout, so we'll actually put our text view right there in our vertical linear layout. And we'll go ahead and we'll center the text on there. And we're going to call this guy number. Trying to come up with a shorthand so you don't have two M's next to each other. Num moves.
I think the game just calls it moves.
Calls it moves. Moves TF. TB. Moves TV. Text view. iOS, it's TF. Text field. All right, so we have moves TV. And we want to set that guy to the number of moves. So we need to give ourselves access to this guy initially. If we want, we can just kind of give it a placeholder of 0. So we need to give ourselves access to that text view. So we'll say private text view moves TV. And then down here, we'll go ahead and get ourselves that text view. So we'll say this dot moves TV is equal to the text view version of this dot find view by ID r dot ID dot moves TV. All right. Then we're going to go ahead and initialize that guy to the starting count. Well, we're going to have to move everything later anyway. So we're going to say this dot moves TV dot set text. Now, do we want it to say moves colon then a number, or do we want it just to say the number? Moves colon. Okay, so we'll say moves followed by a colon. Then concatenate onto that this dot number of moves. All right, so this should show us a 0 initially. Then after each of our moves, we're going to go ahead and update that guy. Make sense? Now, something we might decide to do here, maybe the way we portray our moves might change. Instead of saying moves colon, maybe we'll say something else. So the better programming practice here would be to do this. So we're going to say private void update moves text view. This guy will do that. And then what we would say here is we would say this dot update moves text view. And then down here, we would say update moves text view. That way, if we change the way we were making our text view update, we only have to change it here. And then every place that uses it would benefit from it. Make sense? The other way was kind of maybe bad programming practice, because we would have had to change stuff in multiple places if we decided to make a change. All right, so now we should have a number of moves. There's one move. Oh, I'm already broken. It's 2 moves. 3, and it's going to be a bad game. $11 moves to win. It's terrible. Okay, so now we're keeping track of our number of moves. Now, what about a reset button? So we've seemingly won. And I want to go back to the initial state. How do I restart?
Just clear the tower 3 and restart the T1 at this part, tower 1.
Okay, so if we go back and we see how this originally added, we had our 3 disks, right? This is on create, so there's our 3 disks. Here's our towers. Now, at this point, these disks are local variables here inside of on create. I can move them up here. I could say private disk D1, and then do this for the other 2 disks. All right, so there's my 3 disks. So now their scope is global to main activity, right? So I have access to those guys. So I'm going to go ahead, I'm going to give myself a function here, private void reset game. So really, what are the things that happen to reset the game? Well, I need to have my source mode set back to true. This dot source mode. Was it is source mode? So we start off in source mode as true. We start off number of moves as 0. We need temp to go back to null. Which was its initial value. The 3 disks are fine. We just need to have access to them. But we do need all the towers to empty themselves. And then we need to add those towers to tower 1. But we need all the other towers to empty themselves. So we need to teach our towers how to empty themselves, right? So we go to tower. How do we empty a tower? So pop until the count is 0. Now we do have one issue here. Notice inside of pop, if the disk to return is not equal to null, that's when we actually return something, right? So actually, as of right now, I really only want to remove decrement count if there was something to decrement. Because I can actually break my game right now. I can get my count, some big negative number on tower 3 by continually trying to pop off of tower 3, and then it'll take a long time for me to build that back up to having 3 disks in that tower from a count perspective. So I just move the position of pop. We're going to go ahead and give it a function, public void empty. And what's empty going to do? It's going to pop until pop gives a null. So while this dot pop is not equal to null, do that. So this dot pop gives me a value. As long as the value it gave me is something other than null, keep spinning. Now this is a syntax we usually would not see, right? Because you're seeing a semicolon there at the end of the line. Usually we would expect something like that. But really the reality is I want to do nothing. I want this logic to happen again. So the rule for a while loop, same as a for loop, same as any of these other things, is it's always a loop. It's an if statement followed by a statement. A while loop followed by a statement. A for loop followed by a statement. So this has to be a single statement. This is a block statement. This is the empty statement. Make sense? I literally want to do nothing. Now, if you don't like this syntax, you can write it like this and just say do nothing. That's fine. It's not going to hurt anything. A little bit less efficient, but it's not going to hurt anything. Because actually all the logic we want is right up here. All right, so this should empty a stack. So what we'll do here inside of main activity, yes, good call. Actually, we won't have to reset the count because count counts itself down. Yeah, but it certainly would not have been incorrect for us to just say this dot count is equal to 0 here at the end. We'd be overwriting a 0 with a 0, but it's fine. But we'll just let it naturally count down. All right, so in here, we're going to say clear the towers. So we're going to say this dot t1 dot empty, this dot t2 dot empty, this dot t3 dot empty. And then I like to put this dots in front of these. It's just a thing. So to reset the game, we set source mode back to true, reset our number of moves, set temp equal to null, probably also say this dot update moves text view. That way it says 0 again. Clear out our landing zone. Make sure all the towers are clear. Add our 3 disks to the first tower. All right, so then what are we doing up here? We're just giving ourselves access. So I don't need this guy anymore. So I'll give myself access to my moves text view, access to the landing zone, creating my disks and towers. And then I'll say this dot reset game. Like that. So now what I can do is I can give myself a function for a reset button. So we'll say public void on reset button pressed. This dot reset game. So now we just have to give ourselves a button, set as on click to that. So let's go ahead and put a button maybe above our moves. Right there. Oh, actually I need to have it. No, that should be, where's this guy? Oh, I see. I missed. There we go. All right, so this is our, we'll call this reset button. And then the text he's going to have on there is reset game. On click is on reset button pressed. All right, so we can go ahead and start making some moves. I've noticed I've already screwed up, so like, oh, let's reset that. So go back, hit reset, we're back to 0. Try it again. And there's my 7 moves, and I'm a winner. Okay, so now remind me, we've gone to another screen already, right? Have we done it? We've done intents. Have we only had one screen in our applications up to this point? Okay, so it would probably be nice if we had a second screen to go to, right? Just kind of say winner with a big winner, because, you know, we should have big winner stars. Oh, yeah. Oh, I had to find a use for it. All right, so we're going to save this image as winner TOH. We'll put it in downloads. All right. And I'm going to go ahead and we're going to create another activity here called winner activity. We're just going to kind of set this up and we'll take a break for a few minutes. So I'm going to create an empty activity. So I went under new, activity, empty activity, just like when we originally started our application. We're just giving ourselves a second activity, a second screen in our application. So it's going to be an empty activity, and we're going to call this guy winner activity. And the layout name is going to be activity winner. Make sure you do not have launcher activity checked. It wasn't an option when we first created our project because the activity that is your launcher activity is the first activity that shows up. We don't want to replace our current launcher activity with this guy. So notice it's unclicked by default, which that's how we want to leave it. All right, so we're just creating a new activity. We want it to generate our layout file, and we'll go ahead and click finish. Hit OK. All right, so now here's my activity winner XML. And what I want to do is I'm going to go into my resources here, and we have a folder here called drawable. All right, so drawable is where we have images. So I'm going to right click on this guy, and let's see. Is it drag and drop now? Looks like it might be. Yeah, I think it is just a drag and drop. So let's try it. So we're going to click here to my image. I'm going to drag it over here. We're going to try to put it in that folder. Let's see what happens. It's not there. Can I drop it in the thumbnails? No. We could definitely do this out of the file system, but there should be an easy way of adding it here. No, that's for a brand new file. Unless if I do it in the resources. Why? All right, well, so we'll just do it this way. I'm going to go to Reveal in Finder. It's going to show me my folder here. So here's my drawable folder. And I'll take my dude here. We'll drag him in there. Oh, unless maybe a .gif isn't an allowable format. Oh, he's there now. So it was a fine, nothing wrong with it. So now I should be able to go into, let's hide this, go to my winner, go to my images. I'm going to have an image view. So we'll throw an image view in here. And we're going to have it be our winner guy. Oh yeah. But I like to put these guys in linear layouts, so we'll throw a layout here. We're going to have a vertical linear layout. And then we'll throw our image inside of that vertical linear layout. Although it did look better before, didn't it? Because now he's being constrained by his so I have it wrap content now in this guy, and we just made the image taller. All right. That looks decent, and then let's give ourselves a text view above the image. And we'll have this guy say winner. And let's jump up the size of the text. Make it bold and italic and centered. Good enough. Okay. So our goal here would be now to get us to this screen, then go back and have the game reset. All right, so let's take about a 10-minute break. We'll come back and we will make that happen.